Friends, look at this ordinary teaspoon in my hand. In our daily lives, a teaspoon of sugar or salt weighs maybe 5 grams. It's light, it's simple, it's insignificant. But what if I told you that in a distant corner of our universe, there exists a material so incredibly dense, so packed with matter, that just one single teaspoon of it would weigh more than Mount Everest? Yes, you heard that right. We are talking about nearly 1 billion tons, or 900 billion kilograms, packed into a space no larger than your thumb. How is this even physically possible? If you tried to put that teaspoon on the Earth's surface, it would instantly sink through the ground, through the crust, and fall straight to the center of our planet because the Earth's surface simply cannot support that much weight in such a small area. Today, let's go on a journey to understand the mind-bending reality of neutron stars. We will look at how they are born, why they are so dense, and what would happen if you actually tried to visit one. To understand how something can be this heavy, we first need to understand a shocking fact about our own bodies and the world around us. Science tells us that 99.99% of an atom is actually empty space. To give you a clear analogy, imagine an atom is scaled up to the size of a massive football stadium. The nucleus, the center where all the mass lies, would be just a tiny marble sitting right in the middle of the pitch. The electrons would be like tiny gnats buzzing around the very top rows of the stands. Everything in between that marble and those gnats is absolutely nothing. It is empty vacuum. This means that you, me, the mountains, and the buildings are all essentially empty. The only reason I can't push my hand through this table, or why you don't fall through the floor, is not because matter is solid, but because the electrons in your body are repelling the electrons in the objects around you. It's an electrical keep-away game. But, friends, what happens when the force of gravity becomes so powerful that it wins this game? What happens when gravity becomes so strong that it destroys this empty space entirely? This phenomenon occurs during the violent death of a massive star. Our sun is a medium-sized star, but there are stars out there 10, 20, or 30 times larger. For millions of years, these stars stay alive because the heat from nuclear fusion pushes outwards, fighting against the pull of gravity. But eventually, the fuel runs out. The fire goes out. And in that moment, gravity, which has been waiting for millions of years, finally wins the tug-of-war. The star collapses or inward at a terrifying speed, about 25% the speed of light. Imagine the entire mass of a star, much bigger than our sun, shrinking down into a ball only 20 kilometers wide, about the size of a city like Delhi or Mumbai. During this collapse, the pressure is so high that it performs a cosmic magic trick. It takes those electrons flying around the stadium of the atom and forces them to crash into the protons in the center. In physics, when a negative electron and a positive proton are crushed together, they turn into a neutron. Suddenly, the empty space is gone. The stadium is gone. Only the marbles remain, and they are packed tightly against each other, touching side by side. This is a neutron star. It is essentially one giant atomic nucleus the size of a city. Because all the wasted, empty space has been removed, the density becomes legendary. If you took every single human being currently living on Earth, all 8 billion of us, and you squeezed us together until all the empty space in our atoms was gone, the entire human race would fit inside the size of a sugar cube, and that sugar cube would weigh as much as the entire human race combined. That is exactly what a neutron star is. It is matter with the air squeezed out of it. Now, let's talk about the gravity on such a place. Because so much mass is in such a small space, the gravitational pull is 2 billion times stronger than Earth's. If you stood on the surface of a neutron star, which is impossible, but let's imagine, your body would be instantly crushed. Not just crushed like a tin can, but crushed into a layer of plasma only 1 atom thick. Even the surface of the star is extreme. It is covered in a crust of iron. But this iron is 10 billion times stronger than any steel we can make on Earth. The mountains on a neutron star are only a few millimeters high because the gravity is so strong it flattens everything. Yet, because the density is so high, climbing one of those 5 millimeter mountains would require more energy than a human uses in their entire lifetime. And these stars are not just sitting there quietly. They are usually spinning at incredible speeds. Some rotate 700 times every single second. Imagine a city-sized mountain spinning faster than a kitchen blender. As they spin, they shoot out beams of radiation from their poles, like a cosmic lighthouse.